Hello everyone, this video is pertaining to railway engineering. So first, the capacity of railway track. So the capacity of railway track means the number of trains that can pass safely on a track in an hour. Say for example, there are two tracks A and B. On track A, there are 4 trains was passed safely in an hour, and on track B, there were five trains were passed in an hour. So the capacity of railway track A is 4 and the capacity of railway track is B. So the capacity of railway track B is greater than the capacity of railway track A. So before going to further, first we need to understand the components of permanent way. So permanent way is nothing but the keeping all components in an appropriate position. So first, uh, the the first one at the below was formation or subgrade, which is acts like a foundation for the track, and on that there was ballast in India, which is mostly granite, and on that there was sleeper and again rails. So the purpose of ballast is to keep the sleeper and rails in a proper position and to absorb the vibration loads and to drain the water. So if this is a in a top view, if this is a railway track, then this longitudinal member was called as rails, and the lateral members which are perpendicular to the rails is known as sleepers. So today sleeper were almost made with a pre-stressed concrete. Okay, and then gauge. So gauge is the clear distance between the two rails. So this is the gauge. In India, the standard gauge is broad gauge, which is 1.676 meters, and meter gauge is the length of the meter gauge is 1 meter, and the narrow gauge is 0.762 meters, and the light gauge is 0.610 meter. The world standard gauge was 1.483 meters. In the initial days, there are a double-headed rail. The head and the foot were the same dimension. So the idea is to the idea is when the head is get worn out, the rail is inverted and again reused. But what happened, the foot also get worn out before head, so again leads to an introduction of another rail, which is bull-headed rail. So here what they did, they have added more material at the top head, so that they have achieved the uh, again they have achieved the inverted reuse capability. But what happened, they it not satisfied the stability. The lateral stability was not achieved, so that it leads to another rail, which is flat-footed rail. So this rail was invented by Charles Vignol. So essentially, this rail is also called as Vignol's rails. Now almost 90% of the rails in the world was made as a flat-footed rail or Vignol's rail. So here in railway engineering, there are two ways to measure the gradient. As in the case of highway engineering, there are only one way, which is for a rise or fall of 1 unit with respect to the horizontal distance. But here the rise or fall of a 1 unit with respect to the 100 units of horizontal distance. And again, as in the same, in the highway also, here also, the unit of rise or fall of a 1 unit with respect to 1 unit of horizontal distance. So it is measured in the percentage. Here in the case of the first case, if the gradient is 4%, means 4 units of vertical with respect to the 100 units of horizontal. So here there are 4 types of gradients, but in the case of highway engineering there are only 3 gradients. In the case of highway engineering there are only 3 gradients. They are ruling gradient, limiting gradient, and exceptional gradient. But here in the case of railway engineering there are 4 gradients. One is ruling gradient, which is a design gradient. There are 2 parameters for this, or conditions. In a plane area, the ruling gradient could be 1 in 150 to 1 in 200. In a hilly area and mountainous area, the ruling gradient is 1 in 100 to 1 in 150. And another gradient is momentum gradient. Here what happens, the falling gradient is followed by the rising gradient. For example, here it's a sectional wave. Here there is a falling gradient, and then again is a rising gradient. In this case, the movement which is developed here, the potential energy get converts to kinetic energy, so that it can accelerate and easily climb this rising gradient. So there is no need to provide additional engine or energy. So such gradient is known as momentum gradient, where signals must not be provided. And another gradient is helper or pusher gradient. If the area is very steep and there were too many mountains, then the helper or pusher gradient is provided, which means there is another engine at the end of the train which pushes the train towards the motion of the train. The helper or pusher gradient mostly we can see in Darjeeling, where the gradient could be 1 in 25. And another one is gradient at station ends. So at station ends, the minimum gradient is provided to drain the rainwater. It is generally 1 in 1000, maximum 1 in 400. So here there is another parameter, grade compensation. So as in the case of highway engineering, here also the same thing. When the gradient and the curve both comes at a one point, then the grade has to be compensated. But in a highway engineering, there are two formula given by IRC, which are 30 plus R by R, and another one is 75 by R. But here there are no such formula. There are 3 conditions according to the gauge. So for a broad gauge, the grade compensation could be 0.04% per degree of the curve. For meter gauge, it is 0.03% per degree of the curve. For a light gauge, it is 0.02% per degree of the curve. So there are certain conditions for the maximum degree of curvature. There, for broad gauge it is 10 degrees, for meter gauge it is 16 degrees, for light gauge it is 40 degrees. And here is one question. They are asking that the grade compensation on a 4-degree curve on a broad gauge railway track is. So as we know that if a broad gauge is provided, the grade compensation could be 0.04 percentage per degree. So there are 4 degrees, so the grade compensation is 0.04 percentage multiplied by degrees, which is 0.16 percentage. So how do we measure degree of the curve? So it can be related with the radius of the curve. For example, this is a curve, the degree of the curve is d and the radius is r. So here is the length of the curve. Generally the length of the curve while determining the relation for degree of the curve and radius, the length of the curve is taken as 30 meter or 20 meter. Here in the case we are taking 30 meters. So the length of the curve is 30 meter, and which can also be determined as the slope into radius or into d. Here the degree of the curve is in degrees. We need to convert this in radians. So pi by 180. So here 180 into 30 by pi d. Radius equal to, which essentially gives is 1718.8 by d. Approximately it can be taken as 1720 by d. So this is the relation for radius and the degree of the curve. So say speed and curves. There are some formula given by Martin, which is most important, where the transition curve is provided or present. For example, if this is a curve and it is a straight, so a transition curve is a curve which is provided in between the straight and the curve. So here the transition, the main purpose of the transition curve is the radius gets converted from infinity to the actual radius of the curve. So this portion is known as the length of the transition curve or transition. This is the transition curve. It is provided in between the actual curve and the straight portion. So if transition curve is provided, the speed of the safe speed of the train is v in kilometer per hour equal to 4.35 into r minus 67 under root r minus 67, where r is in meters and the speed of the train is in kilometer per hour. So it is the maximum speed is taken with this formula is 50 kmph. So if the speed comes more than this value, it is restricted for 50 kmph. So if there is no transition curve is provided, it is taken as 80% of the speed, which is limited to 40 kmph. The 80% of the speed which is obtained from this formula is greater than 40 kmph, then it is limited up to 40 kmph. For high speed tracks, the formula was given as v equal to, where v is in speed in kilometer per hour, v equal to 4.58 under root r, where r is the radius in meters and v is the speed of the train in a kilometer per hour. So this is about railway engineering. So here is another question. So what they are asking is, in a broad gauge railway track, the specified ruling gradient is 1 in 250. The actual gradient or specified gradient is 1 in 250. So which is in percentage is equal to 0.4%. The horizontal curve of 3 degrees and that gradient. So what is the compensated gradient? So they are given the gradient which is the actual gradient, and also they given the degree of the curve as 3 degrees. So they are asking the compensated gradient. So we know that for broad gauge the gradient compensation could be 0.04% per degree. So here it is 3 degrees. So the gradient compensation for 3 degrees is 0.04% into 3, which is 0.12%. So the compensated gradient is equal to the actual gradient, which is 0.4%, minus grade compensation, which is 0.12%, which comes out to be 0.4 minus 0.12 is equal to 0.28%. So this is the compensated gradient in percentage. So you need to convert this percentage into ratio. So here 1 vertical to the 1 unit of vertical to the horizontal distance into 100 equal to 0.28%. So here the h is equal to 100 by 0.28, which gives 357.14, which is approximately taken as 357. So the compensated gradient is 1 in 357. So this option B is the correct answer. So thank you for watching. In the next video we will discuss more about some technical terms and the super elevation. We also solve some problems. Thank you for watching.